Hi everybody, welcome back to class. In this section, or in this video, we're going to be continuing our discussion with physical properties of matter by focusing in on one property in particular, that being density. So density is when we're looking at the amount of matter in a given space. One way you can think about this is whenever you pack a suitcase. The suitcase only has so much space. It can only expand or stretch to so large. But sometimes we pack a suitcase light and it's real easy to zip it up. Other times we pack a suitcase, or we attempt to pack a suitcase so full of clothes, and we shove them in there, we stuff them in there, we cram them in there, we do a suplex off the dresser into the duffel bag or onto the duffel bag, and then we try to zip it up. We try to shove as much as we can in there. It's the same bag, but we try to fit more stuff in it sometimes than others. Whenever you try to fit more things in it and you're shoving that, trying to shove it shut, you're trying to crush it down, at that moment, it's more dense than whenever you pack it normal and there's less clothes in there and it zips up easy. Density is looking at the amount of stuff in that space. So when there's more clothes in that same little amount of space, the bag is more dense. When there's less clothes and you can zip it up easy, it's less dense. Now, the other thing with density is unique for every substance. And when you look at different substances, um, none of them will have the same density. You can have objects that have similar densities because that's a whole different thing because they can be made up of different substances. But a pure substance, that's what we're talking about when you say substance, like gold, copper, iron, steel. All of these things will have very unique densities, which makes density a very good physical property to know when you're trying to identify something that's unknown. When you want to figure out what a specific rock is, what a specific mineral is, what a specific metal, anything like that, when you're trying to figure out what it is, knowing the density of it or being able to calculate the density of that substance or even an object is a very good physical property to know because of how specific that physical property is. Now, when we look at density, we're going to be looking at mass and volume. It is a property of matter, and matter is anything with mass and volume, but density is dealing with mass and volume in particular. And to use them, we're going to be using them in the equation like you saw down below, where density equals mass divided by volume. Now, whenever you abbreviate these, you get density is abbreviated with a lowercase d, mass is a lowercase m, and volume would be the v. And here's the different units for it. So we get mass over volume. So density is grams per milliliter, or grams over milliliters. And the other one you can have is grams per cubic centimeter, or grams over cubic centimeter, however you want to say it. But you're most always going to hear it as grams per milliliter or grams per cubic centimeter. The grams is for mass. For this year, for this section, whenever you go to calculate density, you're going to have mass in grams. You will see densities where they use kilograms, and they also use meters cubed, or some of them will even use liters. But we're not going into that. The only units you need to understand for density is going to be grams per milliliter and grams per centimeters cubed. Those are the only units for density we are going to use this year. Mass is, whenever you're calculating density, will always be in grams, and volume will be milliliters or cubic centimeters. Remember, milliliters is going to be used more for the volume of liquids. Cubic centimeters is going to be used for the volume of a solid. So what I have here is this little image with these different smiley faces, and this is kind of going back to the concept of the suitcase or the bag that you're trying to pack full of things. This is not how density and matter really works, but it's giving you a visual to show you the density of something. One smiley face is going to equal 1 gram, and that isn't actually how it happens with atoms, but that's just what we're going to use here. In each one of these cubes, or each one of these squares, we're going to imagine that it's a cube, is 1 cubic centimeter. We're going to imagine that it's a cube, even though it's just a two-dimensional square. We're going to say each one has a volume of 1 cubic centimeter. So in this first image, you have a density of 12 grams per cubic centimeter. What that means is you have 12 grams or 12 smiley faces per 1 cubic centimeter. So in each one of those cubes, you have a density, or in the cube on the left, with each one of those smiley faces, you have 12 grams per cube, or in that one cube there. When we go to the middle cube, if you would count up all the smiley faces, you get 29 there. So you have a density of 29 grams per cubic centimeter. And the reason I'm writing it or having it come up as 29 grams per cubic centimeter, like right here, and down below to make it look like a fraction, is so you understand when we say 29 grams per cubic centimeter, I'm saying there are 29 grams in every cubic centimeter. So every time you have a cubic centimeter of that substance, it would be 29 grams. There's a ratio going on here. So 29 to 1 here. There's a constant ratio of the mass to volume. And that substance, no matter how much you have of it, will always have that ratio. And the last one is 57 grams per cubic centimeter, or there are 57 grams or 57 smiley faces here in every cubic centimeter. And this is just to show you a little bit more about density itself and how the more packed something is. And you can see on the left here, there's not much stuff in there. On the far right, there's smiley faces crammed in there. So it's going to be the most dense because there's more stuff packed in the same amount of space. And that's what we're looking at with density. The more dense something is, it means there's more stuff, more matter when we say stuff, shoved into that same amount of space. Now with density, let me move this for you. Density is going to be a very large factor when deciding whether a substance or whether an object is going to sink or float in another substance or object. Density is a very large determining factor whenever you see a piece of wood that's floating down the river, why it'll float on the water, but a rock will sink, or why some logs you'll see finally sink under the water and others do not. In general, when you're looking at densities and sinking or floating, more dense substances will sink either in or under less dense substances, and I'm going to go over that down below here. And then less dense substances are going to float in or on more dense substances. And this is what's going on with the example below. You have liquids here, honey, water, and oil. And liquids, based on their density, will stack on top of one another. This is how you get the oil and water. Whenever you see oil and water, the oil floats on top. This is also why if you buy certain dressings, you see the dressings separate out and you almost have two different layers there. Sometimes you have more than two different layers. Those layers are separating because of the densities of the substances that are inside of the dressings. In this case, with oil, water, and honey. Honey has a density of 1.42 grams per milliliter. Water has a density of around 1.0 grams per milliliter. And oil, it'll vary a little bit depending on that oil there, of about 0.91 to 0.93. That type of oil, we're looking at vegetable oil right now. So because honey has the highest density, it sinks underneath oil and water. It doesn't matter if you add it first, second, or third. Honey will always go to the bottom. If you add it last, it'll fall through the other two substances, oil and water, and fall to the bottom. If you add it first, everything's just going to sit on top of it. Oil, on the other hand, has the least density. It has the smallest density. So it's going to float on top of that water there. And the water, because it falls in between of the two, will be in between. And you can add different liquids to this. If you ever try this at home, make sure you would have your parents' permission. But you could actually try this with the different liquids that are at your house and see if they will sink or float on top of one another. You might not know the exact density of something, but you can start to infer what that density is. Now, the nice thing is most things, again, have very unique densities. So there are data tables out there of densities of all these different substances, whether they're compounds, elements, um, and you can look them up. You can look up the density of honey. You can look up the density of water, of vegetable oil, of rubbing alcohol, of maple syrup, of Dawn dish. You can look up the densities of all of these after you would do stack these liquids or beforehand, and you can figure out best, okay, did uh, if you did this without having the densities of oil, water, and honey, would the densities that you find match up with the results that you're seeing? So we move on to the calculation parts of density. And when you're calculating density, this density triangle will be very helpful. Now, how you use this density triangle is whatever you're trying to calculate, you're going to cover it up. For example, if you want to calculate density, you cover up the D on it and the division or multiplication sign there. What you have left is mass divided by volume, mass over volume. Whenever you want to calculate something else, you cover it up. So if you want to calculate mass, you're going to cover it up, and it tells you to take density times volume. If you want to calculate volume, cover it up. So volume equals mass divided by density. So between all these, density, mass divided by volume. Mass is density times volume. And then volume equals mass divided by density. So here's where we're getting into the actual calculations. In the first example here, it says a piece of tin has a mass of 16.52 grams and a volume of 2.26 cubic centimeters. What is the density of the tin? So I'm going to just set it up real simple. We're going to have first a density triangle here. We have to calculate density, so we're going to cover it up when we see mass divided by volume. And I'm going to set it up like this. Density equals mass divided by volume. So I have mass over volume, which is basically fraction division. What you then got to do is plug in each piece in the proper spot. Mass is 16.52 grams because grams is a unit of mass, and volume is going to be 2.26 cubic centimeters. Then all you're going to do is plug this into the calculator. 16.52 divided by 2.26. And you're going to get this really long number. 7.3097345133 grams per cubic centimeter. Make sure you write the unit like this. The units do not cancel, they do not go anywhere. So you need to bring them with you, and you have grams per cubic centimeter, grams over centimeters cubed or cubic centimeters. But we're going to round this answer at the hundredths place, which comes out to be 7.31 because the 9 is going to round the 0 up. So let's work on the second one. At this time, what I would like for you to try to do is solve this on your own. What we find here is, again, we have density equals mass divided by volume. They give you the volume, they give you the mass, and they want to know what the density is. So you plug everything in the proper spot. 43.5 grams is going to be your mass, and 50 milliliters is going to be your volume. When you plug it into the calculator and take 43.5 divided by 50, you get 0.87 grams per milliliter. So that's how you calculate density, mass divided by volume. Well, now let's go into volume, calculating volume. So again, we have our density triangle, and we're going to be calculating volume. So when we calculate volume, we cover it up, and we get mass divided by density. So let's work through this first one here. It says an 800-gram boulder has a density of 8 grams per cubic centimeter. What is the volume of the boulder? So we're given density, we're given mass. Let's use the equation we're given. Volume equals mass divided by density. The mass is 800 grams. The density is 8 grams per cubic centimeter. Now, on your slides, I have these two little lines sitting right up above. I think they're sitting right here. So what I did is I left them there so you could just drag them into the proper spot. But what you have is a grams in the numerator and a grams in the denominator. When you have two of the same units, one in the numerator, one in the denominator, they cancel just like X's or W's or Y's or Z's would in math class or in algebra class. So those grams would cancel out. And the reason you want to know that is because volume, you want to know what is the volume. The only unit for volume here is going to be cubic centimeters. So 800 divided by 8 is 100. And because there's a cubic centimeters, that's going to be the unit of volume. Let's move on to the other problem here. I want you to try to work through this one on your own now and solve it. So what we have here is, again, volume equals mass divided by density. The mass is going to be 65 grams. The density is 5.45 grams per milliliter. Again, you should have those bars there that you can put them down there. If not, make sure you copy them from above here and just paste them and drag them over into the proper spot. But the grams cancel out, and the only unit you're left with is this milliliters. When you put this in the calculator, you get 11.926605504, and that's just too big of a number. So what I want you to do is round it at the hundredths place. And you get an answer of 11.93 milliliters. Because again, calculate the volume. You want to know the volume, and that's going to be your unit of volume. So the last type of problem we have here is calculating mass. And to calculate mass, you're going to take density times volume. And I know we haven't worked through one of these, but I want you to try to solve this one on your own right now. Okay, so let's work through this problem now. The first thing you got is the equation, mass equals density times volume. Then plug each piece into the proper spot. Mass equals 2.5 grams per milliliter times 15 milliliters. Now what happens is we only want grams, we want mass. And actually the milliliters are going to cancel out. Now you're going to ask me, well, Mr. Krupa, how do those cancel out? This is multiplication, not division. Yes, I know that, but you got to remember how we originally looked at density. We originally saw density like this, 2.5 grams in every 1 milliliter. This is basically a fraction. Whenever you're writing this here, even though you write it as 2.5 grams per milliliter, that's still 2.5 grams per 1 milliliter, which is a fraction. And if you look at the fraction, the milliliters is in the denominator, and when you multiply, the 15 milliliters is in the numerator because 15 over 1 is still 15. So what happens is those milliliters cancel out, which is how you're left with that unit grams. So you've got to remember how density is actually written. 2.5 grams per milliliter is 2.5 grams in every 1 milliliter. And remember that per basically means a fraction. So what you come up with is a mass equaling 3.75 grams. That would be the end of this section on density. You are going to have to go through calculations, so please do refer back to these slides here. The other thing you're going to have to be working with, if I can go back fast enough, is going to be working, oh, gotta go quick. This slide is understanding that more dense objects or more dense substances are going to sink under less dense substances. And less dense substances or objects are going to float in or on more dense substances. Also remember that density is very, very unique. to for every substance. If you have any questions on this topic, please feel free to email me or reach out to me. Thank you, everybody, and I hope you have a wonderful day.